So today we will cover 8.2, angles and unit circles, okay? So now, as you see, from now on, we're not talking about angles inside of a given object anymore. We will bring that angle measurement onto the wide open quadrant. As you see, there's a center, and we do have horizontal axis and vertical axis, and they meet at the center. Then notice that right side of the horizontal axis that there is a dot, right? Then let's see what happens. So now we call that position as initial ray. Okay, then why is it called initial ray? You will see it. Then if an angle constructed by these two rays, and the one that is positioned in the right side of the horizontal axis will be initial ray, that means we are starting measuring the angle from that position. And the other ray, you know, like make an angle, it takes two rays, right? From starting and then ending. So that where the angle measurement ends, and then we call it terminal ray, right? Terminal ray, or sometimes it says terminal side, okay? Then you just saw how that green dot moved. Once again, from initial ray towards the terminal ray. So now, that way we can count an angle positively, counterclockwise from initial ray towards the terminal ray, counterclockwise, and we measure the angle positive. So I emphasize the positive. That means there's a way that we measure an angle negative, right? So how do we measure an angle negative? Still, it starts from the initial ray. The initial side always placed on the right side of the horizontal axis. Now, if the terminal side of the angle is placed in quadrant 4, then you want to measure the angle from initial side towards the terminal ray that way, which is clockwise. Then we measure the angle negatively. Once again, so if we have big angle, it's greater than 180, but now, just like this, if from the initial ray all the way to the final ray in clockwise, then whatever the angle measure is, and then it's negative. So then that's where the terminal ray is, right? Then let's say we just measured one angle negatively 225. Then we pass negative 90, and then it's gonna hit the lowest point, and then 90 more, in total negative 180, and it's gonna hit left side of that horizontal axis. Then we go 45 more, then we stop there to measure the angle, and it's gonna be negatively measured 225, right? Then in the video that you just saw before you came to my Zoom, and they were talking about, the teacher was teaching you guys how to get the coterminal angles, right? So let's say we just measured negative 225, right? It's negatively, it's clockwise. Then what could be the terminal angle of this given angle, that negative 225, right? So then now you know your terminal side is here, right here, right? Then with that angle, the first coterminal angle that you can easily find will be this. From the same position where it started, the initial side, and you can go until you hit the terminal side that you designated before. Then the green part was measured positively. Why? Because it's counterclockwise and then now it's positively. How much the measurement, how big is the measurement? It's positive 135. And then the green part is the coterminal angle. Why is it coterminal angle? Because it's two angles, negative 225 and positive 135. They are sharing the terminal side here. They are sharing the terminal side. Right? Okay, then is this only coterminal angle? I don't think so. It's gonna be infinitely many coterminal angle. Then what else can we do? Here, once further. Did you see that, how it moves? Once again. So now we are finding more possible coterminal angle of negative 225. The way that we can measure it, you go from initial side and have full circular motion 360 degree. Look, all the way one circular motion, and you go further until it finally hits the terminal side again, right? Then this measurement will be negative 585. So that could be another possible coterminal angle. Then, unless you guys have the condition, for example, a few of the practice problem will say, find the coterminal angle of this given angle theta, right? Between negative 360 to and positive 360 or something else. Unless there's no condition that limits the range, then you can find infinitely many coterminal angles in this way, right? Then what could be algebraic way for us to calculate this angle measure? For example, the original angle, let's say it's theta. Let's call the original angle as a theta, right? Then positive coterminal angle, you can add 360, right? And then from the original angle, if you look for the negative side of coterminal angle, you can just subtract 360. And this can cover this calculation here. So original angle was what? Negative 225. Then the green coterminal angle was going positively. So negative 225 plus 360. And then it does give you 135. And then it was part of that, right? Part of the green angle measure. Then the second one, the original angle was negative 225, and then it was looking for coterminal angle which way? Clockwise, that means negative. So it's negative 360 there. And then if you add both and then keep the negative, and then it does give you 585, but it's negative. So then that matches this angle measure there. Then if you want to go one more circular motion, right? And then you can just go by like 720 and so on, right? Okay, any questions so far? So with this matter, you always just remember the graphical approach of cofunctional on the quadrant, because now we're not dealing with angles placed inside of an object anymore. We're not going to talk about angles inside of rectangle, inside of right triangle, inside of hexagon anymore. So now the angle from the right side of the horizontal axis positioned, so it's especially called, it's a standard position of the angle, right? Standard position of angle means it starts from initial ray placed on the right side of the horizontal axis, and then it measures the angle measure positively to counterclockwise, and then negatively it's just clockwise. Okay, so any questions so far? Okay, good. All right, then clear. Then now let's see the division that we have to get used to on the quadrant with the circle going on. So if we measure any angle from this initial side right here, then on the position, it measures 0 degree. So then from there, starting, you can go 30, and then it's exactly half up to 90 will be 45, and 15 more to 60, and this position is obviously 90. Then we can go further with 120 and 150, 30 degrees more. Then in the middle of them, we will have 135. So that means this is 45, this is 45, this is 45, this is 45, right? And or you can just go by 30, 30, 30, 30, 30, 30. And then all the way there, and of course, we're gonna have 180. In same manner, we go 30 more, 30 more, 30 more, and then we hit 270. On the way, we hit 210 and 240. And then also, this is half, so we will have 225, right? Then again and again and again, and then it's 315, and then like 300 there, 330 there, and then it's gonna come back on where it started. So also, once you finish the one circular motion, it's the same position, but it used to be 0, but now it measures 360. Okay, then especially the way that you see the full circle into this evenly divided fractional echelon is very, very important. And especially when we move to the radian measures of angles, it could be super helpful for you guys to see each sector, right? Each sector, like evenly divided by like 30 degrees, evenly divided by 45 degrees all over the full circle, the pizza of the circle, right? Then that's the essence of that radian measure of the angle. And we will learn that radian measure right after we come back from the 2 weeks, the 2 weeks spring break, okay? So I'm just giving you a heads up that you can see how we divide full circle on 4 quadrants, the 30 by 30 by 30, and then like 45, 45, 45, right? And then you definitely know 90, 180, 270, and 0 or 360 there. And then all this, the evenly divided positions of the angles all over the circle, right? Okay, then save it. Then now, finally, we start constructing unit circle here. So as you see, I didn't change. I didn't really change. I forgot to change this, but 2 pi and pi that you see there, and then that's what we're gonna do when we deal with the radians. Okay, so but besides that, then we can just utilize this diagram. Okay, then now imagine that inside of the circle, we inscribed right triangle. So that means the hypotenuse of that blue right triangle. So let's say this is right triangle here. Then from the center up to where that hypotenuse of the right triangle intersects the outline of the circle, right? So then what we can see is here, we can get the coordinate of this position of that point there, right? Then we will have X coordinate and Y coordinate. Then if we can designate the coordinate there, then we can see all the facts around that circle and inscribe the right triangle like this. And realize the hypotenuse of the blue right triangle is also the radius of the circle outside, right? Then if we designate a certain angle, theta is placed at right triangle down here, then we can call the side down here as adjacent leg. And then the length of the adjacent leg is exactly the X coordinate value. Because this is from the 0, 0 all the way to the end of the side. And then this will be coinciding the X coordinate. And same manner, from the 0 level, how high it goes up to the coordinate will be the vertical leg, which is the opposite leg of the right triangle. And then that's gonna match the Y coordinate here. Okay, once again, clear all of this. Now, we designated one angle of that right triangle inscribed inside of the circle, then we call it theta. Then around that theta angle, the length of adjacent leg of the angle theta is gonna be X coordinate long, right? For example, if we have coordinate 2, 3, that means this is 2 units horizontally, 3 units vertically, right? So then now we have the length of the vertical leg, which is the opposite leg of that theta angle given, will match the Y coordinate of the coordinate on top of that right triangle. And then also the hypotenuse of the right triangle is also the radius of the circle as well. Then this is obviously right angle there. Okay, this is very important diagram picture that we have to utilize from now on in order to construct a unit circle. Okay, does this make sense? Okay. Then in this case, we can get Sine ratio is opposite over adjacent, and then it's gonna be y over, opposite over hypotenuse, right? Opposite over hypotenuse, then we're gonna have y over r, which is the radius. Then cosine ratio of the angle will be adjacent over hypotenuse. So now we can utilize the ratio for the cosine of the angle is x over r. And even tangent will be opposite, which is y, over adjacent, which is x. And we can get all three sine, cosine, tangent ratio with the given coordinate, and then it comes with every single information for us to know, right? Okay, then are we good until how we inscribe right triangle inside of the circle onto that quadrant? Then now we do exactly same steps by using the special right triangle that I mentioned earlier, 30, 60, 90 ratio and 45, 45, 90 ratio, so that we can get the actual coordinates all over the unit circle by using this fact. Okay, ready? Okay, let's go then. Okay, save, clear. Now, over that two axes, horizontal axis, vertical axis, they meet in the middle, and then it's a center right here. And now I notice quadrant one has positive, positive. Why is it positive, positive? X coordinate is positive, Y coordinate is positive. So quadrant one, positive, positive. Quadrant two, negative, positive. Horizontal, negative, vertical, positive. Quadrant three, so it's quadrant two and then quadrant three, and both are negative. In quadrant four, horizontal is positive, but vertical is negative. Then now, imagine that you are using 30 degrees right triangle here. So the theta is 30 here. Then imagine that we put the 30 degree of the special right triangle inside of there. Then, since we know it keeps the certain ratio of each leg, if the hypotenuse is 1, then adjacent leg is radical 3 over 2, and the opposite leg is 1/2, right? Then if we just slide this one to fix it on that position, then when this is 30 degree, the coordinate will be adjacent leg square root of 3 over 2, and the opposite leg 1/2. Then now, move on to 60 here. So now this is theta becomes 60, right? Then imagine that we are putting this 60 degree there. So this is a 60. So then this will be measured as a 60. Then now the adjacent leg of 60 is 1/2, and opposite leg is radical 3 over 2. So the coordinate goes adjacent leg 1/2, opposite leg square root 3 over 2, right? So then with this manner, we can go all the way up to 360 circular motion. So you go you go that way. So now we are measuring 120. Then we can find the coordinate with the length of adjacent and opposite. And we can go up to 150. Then it gives you the measurement so that you can find the coordinate there. And then we can just keep going. And now we measure the coordinates of the 210, 240, and 300, 330, right? So then, at least on the upper right corner, we can see the measurement from the coordinate, and we can have the values of sine 30, 1/2, cosine 30, square root of 3/2, tangent 30 is radical 3/3, right? That this can happen because we are using right triangle here inside of the circle that has radius 1. So that means from the center up to this point, the radius is 1, right? Then sine of the theta is opposite over hypotenuse, but hypotenuse is 1, right? So that means 1/2 over 1, which is 1/2. That's why sine of the 30 is 1/2. In that manner, we can fill the table with this. So now we don't have that much of time that I will skip this. So you should make sure you understand step by step by utilizing these notes, because I already uploaded onto the additional material pages there. And then also I'm going to upload the videos, right? So take some time and repeatedly watch these videos, okay? Then same manner, we can construct the 45 degrees all over the unit circle with the other right, special right triangle with 45 here, right? So quickly, for 45 sine, cosine, tangent value that we are gonna plug this 45 degrees. So this is 45, right? And then the ratio of each leg goes like this. And then it's special isosceles right triangle, and these two legs happen to be the same. Like how we get to the ratio and then everything, and then please watch the separate resource that I uploaded, okay? Then here again, and we can get the coordinate. The adjacent leg is square root 2 of 2 over 2, and the opposite leg is square root, so the radical 2 over 2. Then the sine, then this is also 1. The sine will be radical 2 over 2, and cosine is also radical 2 over 2. Then tangent will be 1, because tangent is opposite over adjacent. Then if we have same value top and bottom, and then it becomes 1. So then with the same manner, we can go all the way to quadrant 2, quadrant 3, which is 225, and then quadrant 4, which measures all the way 315. Okay, then now save this. Then besides those echelons that we can see, now we can figure out the values out of the quadrant angle. Why it's called quadrant angle? because it's just either on like here, 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 where the axes are passing through. So when we have the 0 degree, then sine is 0 because there's no vertical height at all, right? And then the cosine, which is only the horizontal length, which is 1. Then with that, the tangent is opposite over adjacent, which is 0 over 1, it's gonna make 0. Then what about the 90? So once we measure 90, then it's gonna have sine being 1 because it's only the vertical height 1, but there's no length horizontally. So it's gonna be cosine 0. Then in that case, opposite leg over adjacent 0 is undefined. This is undefined, right? Then let's move on to 180. So now we have the coordinate -1, 0. So we will follow the sine and cosine with 0 and -1. Then in that case, the tangent is 0 over -1 is 0. Then move on to 270. Then sine is -1, that's vertical, and cosine is 0, that's horizontal. Then in that case, -1 over 0 will be undefined again. So that's gonna be the values over the quadrant angle. Then if you go back, the 360, then it's the same with the 0 because it's the same position, right? Okay, then recap. So now notice everything that we just observed, how it gives all the values here, right? And then the only different thing is instead of we go by 36, 45, and 60, we do pi over 6, pi over 4, and pi over 3, and so on. These are the radian measures that we are gonna do on 8.3. So I'm just giving you the heads up, right? Then this is what we will eventually learn. So then all these angle measurement and equivalent radian measurement and each position that comes with coordinates. And then it's not only quadrant 1, 2, 3, 4, all over. Okay, so practice problems are mainly asking you about like angle measure and coterminal angles and some values for sine and cosine all over that unit circle. So since this is a big concept that I had to just kind of rush through, right? So you must see the notes again or even the recorded video, right? Okay.